Hi everyone. Today we'll be implementing k-means clustering model from Scikit-learn library to build customer segmentation project. Customer segmentation is usually used by marketing teams to divide customer base into distinct group of individuals that have similar characteristics. That process makes it easier to target specific groups of customers with tailored products and services. We will be using Google Colab for this project, which is a hosted Jupyter Notebook service that requires no setup to use and provides free access to computing resources. If you do not have a Colab account, you can create a free account by signing in with your Google account at colab.research.google.com. I'll put this link in the description box below. I will show you everything step by step. I'm sure this will be fun and helpful project to you. If you stick around until the end of this video, you will be able to build your own customer segmentation model with k-means clustering so that you can add it to your resume or portfolio and even show it to your potential employers. Before getting started, I would like to say that I would really appreciate if you could subscribe, like, and click on the notifications bell to see more videos like this in the future. For a dataset, I looked up to the Kaggle, and if you come here to the dataset section in the left sidebar, you can search here the dataset that you want. In our case, it's customer segmentation. Let's search for it. And you can see here that more than 100 results, and I usually go with the first one. It usually works for me, but let's have a look inside. And here, if you look at the data, we have customer ID column, gender column, age, annual income, and spending score. Well, let's actually use this as our data set. We can download it from here in the download button. And if we jump back to our Google Colab, we can upload it from here, from the upload button. And after uploading, we can start our first step. All right, let's get started. We'll be going through 3 steps in this project, and first one is importing required libraries and exploring data. We'll be using Pandas for this project to work with our tabular data. It makes it easier to manipulate data frames. And we'll also be using matplotlib, which is a library for making graphs and showing images. It's useful for displaying our results. After importing libraries, we can read our CSV data with read CSV function from Pandas. But make sure you have uploaded this or your own dataset before running this cell. And also we are we are setting it to the variable df. And we can also have a look at first few rows of our dataset with head function here, as you can see. And 10 here means it will show us first 10 rows of data. So let's run this cell and have a look if we have read our data properly. Nice. As you can see from here, we have customer ID column, gender, age, annual income, and spending score, as in our original dataset. For simplicity of this project, we'll be using only salary and spending score. More on that later on. Next thing we are going to do is let's see how many rows and columns do we have in our dataset. We can do that by using shape function from Pandas again. So let's run this, and here we can see that 200 rows and 5 columns in our dataset. And also if we run df.info on our new cell, we can see here all of our data is non-null, which is basically means we have really clean dataset. Also here we can see our data types are numerical for all columns except gender. This one is, of course, this one is categorical. Anyways, we won't be using that column today. All right, we are now ready to go into the second step, which is preparing our data and finding optimal number of clusters with the elbow method. Well, a little about elbow method. Elbow method is a graphical method for finding the optimal k-value in a k-means clustering algorithm. And first we'll be extracting values from third and fourth column, which is annual income and spending score, and storing them in a new variable called new data. We can also visualize new data. Let's visualize it with entering new data. And cool. Here we can see only third and fourth columns. By the way, if you are wondering why annual income is very low here in this column, it's in the thousands of US dollars. So here in last row, for example, it means 137,000 US dollars. And now let's import k-means class from Scikit-learn.cluster module. Scikit-learn is a scikit-learn library, a widely used machine learning library in Python. And also let's initialize an empty list named WCSS. By the way, this is not from CSS in the front-end development. It basically stands for within cluster sum of squares, which is the sum of square distance between each point and the centroid in a cluster. When we plot a WCSS with a k value and plot like an elbow, and the number of as the number of clusters increase, the WCSS value will start to decrease. And the idea is to choose a number of clusters k that minimize the WCSS. And our list here will be used to store the WCSS values for different number of clusters. Now let's run this. Next thing we are going to do is let's create a loop to fit the k-means clustering algorithm with different number of clusters and and calculate the corresponding within cluster sum of squares WCSS for each configuration. And here inside the loop, a k-means object is created with the current number of clusters I, and clusters is equal to I, and the init equals k-means plus plus. Parameters specify that the algorithm should use the k-means plus plus initialization method, which is a smarter way of initializing cluster centroids. And also here we are setting a random state to 0. And here this line fits the k-means model to the data, our new data, which is it assigns each data point to one of the clusters. And after fitting the model, the WCSS for the current number of clusters is calculated using the inertia attribute of the k-means object. The WCSS value is then appended to the WCSS list that we have created earlier, capturing the variability with the clusters for different number of clusters. After running this loop, the WCSS list will contain WCSS values for cluster numbers ranging from 1 to 10. This information can be used to visualize the elbow in a plot and help determine the optimal number of clusters for a given dataset. The optimal number of clusters is often where the WCSS starts to decrease at a slower rate. We are having some errors warnings here, but let's not worry, at least for now, and see how it goes. Now let's create a plot to help identify the optimal number of clusters with matplotlib library. Let's set up a title elbow method, and on the x-axis we'll be having a number of clusters, and on the y label we'll be having WCSS values. And here in the last line we have plt.show, which basically visualizes our plot. Cool. We have a plot here, and we can see that line decreased drastically from when number of clusters is 1 to number of clusters is 3, is somewhere 3. And we can see here it starts to slow down until 5, and from 6 it really flattens. So in this case 5 would be ideal elbow, so we can assign optimal number of clusters as 5. Da-da-da-da. Let's move on to the next last step, which is training our model. To do that, first let's start by initializing k-means model to cluster the data into 5 clusters, as we just did before, but only for 5 here. And now let's also fit our data, our model to new data. After running this code, k-means will contain the cluster labels assigned by the k-means algorithm to each data point in new data. Each element in k-means represents the cluster assignment for the corresponding data point. Now let's create a scatter plot to visualize the clusters formed by k-means model. This line here creates a scatter plot for cluster 0 and new data y k-means 0, 0. This part means the x coordinate values for data points in cluster 0 and this one is respectively for y coordinates. And here we have like s is equal to 80. That means marker size is set to 80 and marker color is red. And here in the last part we have a label. It's assigned to the for the legend indicating the cluster number. And also now let's do the same for clusters 1, 2, 3, and 4 as we just did for cluster 0. And here this line adds scatter plots for the centroids of each cluster. We'll be having two centroids, x and y, and these points are marked with black color and larger size. That means like that's why it's 100 here. And here it adds a title, and we have x-axis and y-axis, y label, and we have a legend here. Like it basically adds a legend to the plot, displaying the label specified in the scatter plot commands. And this one basically displays the plot. And let's run this and see how it goes. Voila! We have a nice plot of clusters as we just wanted. Let's analyze this colorful plot a little bit. You can see that customer group 4 with yellow label has lower salary here, as you can see on the x-axis, but higher spending score. And on the other hand, we can also see that customer group 1 with a red label has a higher salary but lower spending score. So if you are, for example, in a marketing department, you may want to target clusters blue and green, which has higher salaries and higher spending scores. If you are here until this part of tutorial and it has helped you, I'm really happy for that. Now you can build your own customer segmentation project with machine learning. Before moving on to close this, I have some upcoming projects and would love to hear your voice on what should I work on next and create a tutorial like this one. Feel free to comment below one of these ideas or your own. And also, it would be so helpful if you could subscribe, like, and click on the notifications bell to stay informed with my upcoming projects and tutorials like this. Also, if you'd like to see more of a machine learning project, I suggest checking out my other video on Apple stock prediction with machine learning. As always, thank you and see you next time.